Hello friends, this is Astha Sharma and welcome back to my YouTube channel. Let's start our internal number fourth. Uh, let's start our discussion. Question number one. Suppose you are given following data item to cluster and we have this set and k equals to 2 using Euclidean distance computation. Apply k-mean clustering and generate final cluster. Let's start our discussion. Uh, 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 Steps are: first, initialization. Set the number of cluster k equals to 2. Second, randomly select two initial cluster centers from the dataset. For example, let's say we choose 2 and 20 as the initial centroids. Second, assignment step. For each data point, calculate the Euclidean distance to each centroid. Second, assign the data point to the cluster with closest centroid. Third, update steps. For each cluster, calculate the new centroid as the mean of all data points assigned to that cluster. Fourth, repeat. Repeat step 2 and 3 until the end centroid coverage. Uh, Question number 1 solution is: we have given that set k equals to 2, 3, 4, 10, 11, 12, 20, 25 and 30. Consider two cluster k equals to 2. Let's mean 1 equals to 4 and mean 2 equals to 12. Step 1, k1 equals to 2, 3, 4, k2 equals to 10, 11, 20, 12, 25, 30. And m1 equals to the mean of k1 and m2 equals to the mean of k2. M1 equals to 3 we get and M2 equals to 18 we get. Step 2, K1 equals to uh, 2, 3, 4, 10 and K2 equals to 11, 12, 20, 25, 30. M1 is the mean of K1 and M2 equals to mean of K2. M1 is 4.75 we obtained and M2 is 19.6. Step 3, again the same mean of K1 and mean of K2, which is M1 equals to 4 and M2 equals to 25. Step 4, we have K1 equals to this and K2 equals to this, and M1 is 7 and M2 is 25. We are getting some means, so the new cluster are K1 equals to this and K2 equals to 20, 25, 30. We got the answer because of the M1 and M2 of step 4 and step 3 are same. So the question 1 is completed. Question number 2. Uh, Consider the following transaction data. T1 is bread, jelly, peanut butter. T2 bread, peanut butter. P3 bread, milk, peanut butter. P4 beer, bread. P5 beer, milk. And I for input support S equals to 30% and confidence equals to 50% guarantee. Valid association rule. Or I. Minimum support equals to 2, minimum confidence equals to 70%. Let's start our question number 2. We have given T1, T2, T3, T4 and T5 and the support equals to 30% and confidence equals to 50%. Minimum support count equals to 30% into n, which is the number of items. Then minimum support count is we calculated 1.5. Firstly, find first item set and its frequency of occurrence. First item set is bread, jelly, peanut butter, milk, beer, where bread is 4, jelly is 1, peanut butter is 3, milk is 2 and beer is 2. Now here the jelly frequency is lower than minimum support count, that is 1, which is smaller than 1.5, hence we remove it from the table. The new frequency frequent first one item set table is frequency 1 item set bread, peanut, milk, beer and frequency is 4322. Now creating two item set from the set of frequency item set, that is bread, peanut butter, milk and beer. Two item set table is this: bread, peanut butter is 3 time occurred, bread, milk is 1, bread, beer is 1, peanut butter, milk is 1, peanut butter, beer equals to 0, and milk and butter is 1. Again, removing the two item whose frequency is lower than minimum support count. Frequency 2 item set bread, 3 item set, no, 2 item set bread, peanut butter equals to 3. Forming association rule. Rule 1, bread is peanut butter equals to 3 by 4, which is 0.75, which is a 75%. The confidence equals to 50%. Here, the rule 1, which is bread peanut butter, is of 75% confidence, hence it is a strong rule. Rule 2, peanut butter and bread equals to 3 by 3 equals to 100%. It is also a strong rule. Question number 2, part B is part B. We have given the items. We have given items T1, T2, T3, T4, T5, T6, T7, T8, and T9. And the frequency is given here. Minimum support count equals to 2. Minimum confidence equals to 70%. Finding one item set and its frequency. This is the table. L1's frequency is 6, L2 is 7, L3 is 6, L4 is 2, and L5 equals to 2. Here all the list items support the minimum support count, hence no item will get removed. So the frequent one item set will be same, that is given here. L1 equals to 6, L2 equals to 7, L3 equals to 6, L4 equals to 2, and L5 equals to 2. Now creating two item set from the set of frequency. One item set, two item set, we have L1, L2, 4, L1, L3 is 4, L1, L4 is 1, L1, L5 is 2, L2, L3 is 4, L2, L4 is 2, L2, L5 is 2, and L3, L4 is 0. L3 and L5 is 1, and L4 and L5 is 0. Removing the two item set whose frequency is lower than the minimum support count. So the frequent two item set is L1, L2 is 4, L1, L3 is 4, L1, L5 is 2, L2, L3 is 4, L2, L4 is 2, and L2, L5 is 2. Now creating three item set from the set of frequency. Two item set, that is L1, L2, L3, L4, and L5. Three item set, we have given this in this table. Again, removing the three item set whose frequency is lower than the minimum support count. Minimum support count. So the frequent three item set frequency L1, L2, L3 is 2, L1, L2, L5 is 2. Now creating four item set from the set of frequent three item set, that is L1, L2, L3, L5. Four item set frequencies L1, L2, L3, L5 is 1. Here, no element support minimum support count, hence we will get for frequent three item set element and generate the association rule. Rule 1, L1 is L2 by L1 by L2 L2 and L3 is 2 by 6, which is 33.34, and L2 by L1 and L3, which is 28.57. L3 by L1 comma L1 and L2 is 33.34. L2 and L3 by 1 is this. Then again rule 5, rule 6, rule 7, and we have 12 rules, and we got the the result. Given that minimum confidence is of 75%, hence the rule 9, rule 11, and rule 12 are strong rules. That is L5 by L1 and L2, L1 by L1 and L5 by L2, and L2, L5 by L1 with 100% of confidence. So we discussed this paper and we got the solution. Now, thank you so much.